So one type of problem you'll see asked is to analyze the runtime from some pseudocode. So I have an example here, and they want us to find how many times the function f is called. And so I'm just going to highlight that in our code just so we can keep track of things. And whenever you're doing any sort of pseudocode or analysis of code, you can always think of loops as summations. Like if you're doing a for loop, it's the same as because you're incrementing your variable usually by 1 for for loops. That's very similar to the structure of a summation. And when you have multiple loops, I recommend to work inside out. So let's start. I realized my pen thickness was too big. So let's try to think this in the form of summation, and let's look at the inner loop. Okay, so what's happening on the inside? J is the variable that is changing, so that's what we're going to put down here. And it's starting from the value 1, and that's given, and it goes until n. And I kind of hate pseudocode because it can be kind of unclear what 2 means, but just think of this as the less than or equal to symbol. Okay. Now, what is it summing? And also, what are we trying to determine in the problem? We're trying to see how many times it's called. Now, it's called once in this for loop. So our sum is going to have an inner value of 1. Now, if this was something like f plus f again, that doesn't really make sense in this context, but pretend it does. Instead of 1, we would have 2 because we're calling it twice. But that's not what this problem is asking, so I'm going to erase that. Okay. So that looks right for our inside. Remember, we have another function call outside of that loop. Okay, now this is our total inside. Now let's determine the bounds for our outer loop, which is our while loop. The variable that's changing is I, so we're going to set I to the lower bound, which is 1, and it goes until n, right? Well, actually no, because this is where it gets tricky. Instead of I incrementing by 1, it's actually being multiplied by 3 each time. And the summation representation assumes that I is being incremented by 1 each time. And let me show you why this is a problem. So if we had it incrementing by 1 time, which is what our current sum is showing, it would look like this, right? But what's happening is it's being multiplied by 3 until n. And so as you can see, it's going to be a lot quicker to get n when you're multiplying. So this function, or this sum, will be iterating less times, if that makes sense. Like the while loop itself will end quicker. So we can't say these are equivalent. So let me erase this because that's not correct. Okay, let's erase this top line. So how do we represent it? So let's think of this as powers of 3, right? Because we're multiplying by 3 each time. Okay, and this goes until n still. Now this is awesome because now we have exponents that are incrementing. Oh, I messed that up. That should be 3. Incrementing by 1, which is perfect because our summations can only increment by 1. So let's assume I is in the form of 3 to some power p, and it goes until n still. So let's erase this. P equals 0, because that's where it's starting from. And then we go until when? So it's going to go until n, which in this format is the same as let's solve actually. 3 to the p equals n. We can log base 3 both sides to get p equals log 3 of n. Okay, so that should be the max value of of p. Okay, so it's going from 0 to log base n. That makes sense, right? Because 3 to the log base 3 of n is still n. So yeah, we're basically just having this in the form of the exponent. Okay. So this is perfect. And we rewrote I, but the nice thing is that our inner sum does not depend on I. So for example, if this variable was I, we would have to change it, but our inner sum doesn't depend on I, so we don't have to change anything. I'll show another example of when you would have to change it, but just remember, the inside doesn't contain the variable I, you don't need to change it. Okay, so now this is just a summation problem, and I'll speed up and just show the answer. So hopefully you try to do this on your own. I've just applied some summation rules that we learned earlier in the course. Here I just want to note that I can only do this shift if the inside does not contain the variable p. That's very important to note, because if it doesn't contain the number p, it's basically saying repeat the inside this number of times. It's not actually changing the value, so I'm able to do a shift. So yeah, that's helpful to know, especially for a lot of the formulas that are given. You have to have the lower bound start at 1. But yeah, you just know you can't always do that. Anyways, so it'll whittle down to this being the final answer for how many times that the function is called. And then if you want to put this in big O, remember that you want to look at the fastest growing term, which is n log 3 of n. So this function, I'll also highlight this just because why not? This code has runtime of n log n. Okay, we're looking at a very similar problem. So again, I'm going to start working from the inside. And let's make this bigger. Okay, the variable that's being incremented is k, so we're going to have k start from the smallest value, which is given, and that's 1, until it equals j. And how many times is f being called? Well, it's being called 1 time. Now we have our outer loop. Again, remember, this is being multiplied by 2, so we need to rewrite j in a form where we can have our loop increment as 1, if that makes sense. So remember, j will be increasing like this, because basically each time it'll start at 1, and then it'll go to 2, and then it'll go to 4, because it's being multiplied by 2 every time. And this will go until it equals n. So our min value is going to be this value here. And let's have this be some power p. Okay, so we're rewriting j to be in the form of 2 to the p. And we need to figure out when does p, what's the value p goes until. So 2 to the p equals n. We log both sides, right? And then we get p equals log base 2 of n. So this is our upper bound. Alright, this is pretty standard from what I showed last time. But here's the catch. Oops, let's not erase all of that. We've changed j to be in this format. And so our inner loop is actually depending on j. Notice on the previous problem, when we changed I, it didn't matter because it was going from n. The inner loop didn't have I in it, essentially, but this problem does contain the value I'm changing in the inner loop. And this is not a big deal. I can just rewrite it in the form of 2 to the p, and that's it. So again, this just becomes another summation problem. So I've just used my sum rules. I didn't show it all because hopefully this is review from earlier. If not, that's okay. Just go review the sum formula sheet. But basically, you can whittle this down to know that f is going to be called 2n minus 1 time. And we know that this is big O of n.